Hmm. Oh, I was using. Okay. I am plugging in my wires, like, and so on, getting set up for the people that are asking. Today is... welcome, it's Lumi. Mm. What? Someone actually saved up enough for change stream. Oh lord. Okay. I have no words. Okay. I will keep my word. Yeah. Okay. Okay, why won't it let me update the stream title? Done. Shout out to something from Juno is a frog. Yep. Shout out to Kanep, Hongkong Bhattacharya, and Bohan Yao from Juno is a frog. Someone saved up enough to change the stream title, which is amazing. I think it should be changed now. If you refresh, the new title is there. Anyways, okay. Cool. I guess it's 7:01, so people can start talking about the problems. Dun, dun, dun. Okay, so welcome to USAMO test review. Actually, I want to make one change to this title. I'm going to go over some subset of the USAMO problems, and I haven't even decided which yet, so I'm really playing this by ear. But I've at least copied the statements of all the problems. I don't know. What problems do people want to see, I guess? Is there any... I don't have any problems on this test. Oh, right. Yeah, this is the fun part where I get to reveal the authors, right? So, the authors are... let me... page. So for JMO... Oh, you guys, do you want to guess the authors again? Actually, I can put these on two separate pages. I don't need to mini page this. Okay, do I really want to do guessing for all 10? Alright, whatever. Okay, some people already claim their problems, so... no, wait, that's the wrong field. I meant JMO. Actually, let's do this by author. I think that makes more sense than doing it by problem. Thanks to mprog123 for the follow. Okay, oh, I only get 5 options. Okay, I guess I have to narrow it down. Okay, here. Have fun. Thanks, xtile0 for the sub. I appreciate it. How do you feel about AMO3? Apparently, I just missed an easy solution. So I'll tell you which problems I actually managed to solve. I got USAMO 1, 2, 4, 5, and not 3, 6. I thought I had 6, and then I was writing up my solution in preparation for this, and I realized it was wrong, and I was really sad. So, wow, that is a very strong consensus. Okay, so J3U2 is not Ankon Bhattacharya, it's Alex Zai. And the other JMO problem is, the other Ankon problem is JMO 6, so better luck next time. Alright. Any others people want to guess? So I already said I don't have any problems on this test. Okay, I'll just reveal the rest of the authors as far as I can remember them. Von Hyman, T2 entry scale. Carl. Kiran Kedlaya. And those of you who follow me carefully may know I always do things by first name rather than last name, so that's the order for the co-authored problems. All right, cool. So let's get started. I can. I'm just going to do day 1 in order because I think that's one that is reasonable. And I'm just going to try to do all 10 problems, and then as I realize that I'm going over time, I will just cut stuff. U2 is hardest on AM. So let's go. So problem 1. The giant text. So favorite problem, I think all the USAMO problems this year are actually quite good. I'm pretty happy with like most. if I had to pick one, it might be... I might say U5. So for, okay, JMO1 is this thing where what you're doing is you're repeatedly swapping adjacent books where the left book is wider and shorter. Okay, so we're going to say definition, a pair of books is height inverted if A, let's say AB, is left of B and taller shoot, I definitely already have a typo in my notes. Okay, taller than B. So I'm going to look at books where you have a... Is there a way I can draw this easily? I don't know. But basically, we're going to look at permutations. And you have this permutation, and then sometimes you have book A to the left of book B, and then sometimes the book A is taller, and then sometimes the book A is wider. So I'm going to look at pairs like this. And well, claim number of with inverted pairs decreases every step. And that's because you swap a with inverted pair to make it not with inverted without changing anything else. Hence terminates. You have a decreasing integer, then you're fine. Okay, second part. So now let's look at a situation where you can't make any more moves. Then assume for contradiction that two consecutive books are still with inverted A, B. What was the Mohs rating? I'm probably not gonna... I'll post my Mohs rating after grading. I don't like to comment on difficulty of problems until after I also see the student papers. Okay, so if they're still with inverted, by hypothesis, they are still height inverted. So the operation couldn't have swapped them. And that contradicts assumption no height inverted pairs originally. That's it. So it stops because eventually you run out of with inverted pairs. When it stops, any remaining pairs that are with inverted must also be height inverted, and then that contradicts that contradicts the assumption that initially there were no height inverted pairs. Is that okay? Is anyone paying attention? I feel like no one actually wants to listen to JMO problems. Alright, so if that's the case, I will... I don't know what the rubrics are going to be. Yeah, I don't know. I feel like people want to see how you do the USAMO problems. So let me speed along through the JMO. Or at least JMO 1 is kind of just like not that fun to talk about. Baba's you today? Probably not. So the reason is that I'm in the middle of Puzzle Potluck, and I was about to I was halfway through the final meta, and then I had to come run USAMO review, and I really want to finish the meta. So, yeah, that's happening. Why is my iPad not rotating? Oh yeah. Alright, there we go. Okay, so... Why is arrows hard? Yeah, arrows is hard. Okay, W2, W. Okay, so okay. So JMO2 is this problem about the locus of an equilateral triangle. And what happens is I have this ABC. Thanks, and Prime, for the cheer. And I guess this is a C index problem, right? So C, A, B. And then I have this tangent line that's moving that hits somewhere here and here. So let me get the labels right. This is P and this is Q. And then what you do is I take these two circles centered at P and Q. One of them has radius PA and the other has a radius PQ. So this is one circle. That's a pretty bad circle. That's good enough. I just need to illustrate. And then there's this Q circle. Alright, and then you get 2 points R. So there's a point, there's two possible places for R, right? R could be here. I'll call this R1 and R2. And the problem asks you to figure out where R1 and R2 are. So, okay, so what do I do? Well, what's the answer to the problem? If you actually do this thing and you trace out the locations of R, what you'll find is that there's two arcs that you can live on. One is that there's an arc here. That's not a great diagram. Freaking. Okay, whatever. We can pretend that's like approximates the circle. That's because I'm doing freehand. And the other is like there's a giant arc all the way up here. Okay, so the arc that's close to the circle seems like it's more promising. What happens is if you just draw the picture, what you'll find is that these points R are moving on the circumcircle of ABC. And you're like, oh, really? Well, if that's the case, what's going on? So what I'm going to do is I'm going to introduce this point T, where PQ is tangent to the incircle. And here's the big claim. One of the points R is the dilation of T across the incenter with factor, let me just say -2. So what I do is I take the incenter, and my claim is that if I take the incenter and dilate this in a 2-to-1 ratio, then this point R will lie on both circles. And okay. Why is that? So let me make sure I get this right. Well, if I do this homothety, then there's this sort of isosceles trapezoid here. Let me mark 2 new points. Let me call this one M. So M is the midpoint of BC. So we define R. Let's redefine R prime as this point. Then Where'd my editor go? TMR prime A is an isosceles trapezoid. Basically what happens is this whole image is just a reflection of, actually, T, M, and A R prime are reflections across line PI. Because AI to AIM is 2, so you get that. And similarly for the other one. So this problem is kind of weird because once you know the correct characterization, it's basically, there's nothing to prove. You're like, oh, I realize that it's this point, and then it's just redefine R prime to be that point. Now it's everything symmetric around PI and then respectively QI. So you automatically get PA equals PR prime here. And similarly for the other one. So that already gives me that I can, if I take a point T here, then everything on this lower thing is there, this lower open arc. How many points do you get if you just draw a diagram? I can tell you that's 0. Like, you don't get a point just for drawing a picture. Just to dispel that common myth. Yeah, so that gets us one of the points, and you're like, okay, great. What about the other one? Evan, this ad, let me wait until after day 1, and then I'll run an ad break. Okay, the reflection, I have that other point here. So what's going on? Well, I know that this guy is R, this guy is 2R, so this reflection is 3R. So since IR2 equals 2R plus R equals 3R, it follows that R2 lies on the doubled circumcircle. So if R is the in radius, then this is the, IR2 equals R plus 2, 4R. So it lies on the doubled circumcircle, again with center I. So it's this arc here with radius 4R that's sort of just opposite the previous one. And that's it. You actually don't even need radical axis. You don't even need to angle chase. It's just like, once you characterize the point, the lengths that are given are clear, and then you have, you know, you would take 1 plus 2 plus 2, and that's like 4R. That's the whole solution. If you forgot the other intersections, I have no idea. Ask the captain. Who I need to talk to at some point to set the rubric. So just to preemptively answer all the rubric questions, the answer is I don't know because I haven't seen any of the rubrics. I'm normally a bit more on top of that, but I spent the entirety of the last 2 days doing puzzle potluck, so I was not on top of my USAMO stuff. Okay, let's do the other geo. Yeah, this year's puzzle potluck is so good. It's like, oh man, it's crazy. Okay, so in the other geo problem, I have okay, so this is another C-index triangle, right? I don't know why all the triangles are C-indexed. CAB, and then I pick like a random point D, or sorry, point X, and then you have D, and then there's like a circumcenter here, and there's like a circumcenter here, and then O also has a center, that's not changing, and you have this triangle and you want to minimize the area. Okay, so what I'm going to do is first, there's the obvious angle chasing thing, which is that claim O01, O2 is similar to the fixed triangle ABC. And the reason is that wait, why is it not working suddenly? Okay, yeah. So angle 00102, because the lines are perpendicular, it's equal to angle AXC. So I definitely flip the, okay, let me get the order right. 00102. So O should be C, BA. Okay, so 00102 is equal to AXC because what I do is I rotate all the lines by 90 degrees. So 001 and 0102. 001 was perpendicular to AX because those are both a perpendicular bisector, and then 0102 is just perpendicular to CX, again because of the angle bisector. So that's equal to AXC, which is fixed. It's actually equal to ABC. Similarly for the other one. So yeah, 00102 is equal to... I'll draw it just so that people can see what's going on. Like, because this is perpendicular, that's not actually supposed to lie on it. There's a right angle here and a right angle here. So this angle is equal to that angle is equal to that angle. Okay, and similarly for the other ones. So what that means is that just need to minimize 0102. Now, if you have done way too much geometry like me, the first thing I did when I saw this was like, okay, great. X00102 is similar to XAB by Selman theorem or whatever. Or there's other reflection things you can do. But it was recently brought to my attention that the dumbest thing possible actually works. This is what the dumbest thing possible is. 00102, let's project it onto AB, right? So this length here, because of the perpendicular bisectors, is always half of AB. And the angle is like some random angle. So 0102 is always equal to AB over 2 divided by the sine of the angle between, or sorry, cosine of the angle between 0102 and line AB. It's like the cosine of that green line and this black line. Okay, so this guy is fixed. AB over 2 is fixed. This line AB is fixed, so to maximize it, you want to make angle 0, i.e. 0102 is parallel to AB, i.e. CX is perpendicular to AB. And therefore the minimum occurs if CX is perpendicular to AB. Uniquely. And that's it. Oh, my head is slightly covering the text. That's not great. Yeah, so I totally got baited. I went after the Selman angles, and that was just like the wrong thing to do. So you literally, that's it. You need to observe the similar triangles, and then you write down one cosine, and that cosine, that's it. The end. Thanks, I'm Primo6 for the cheer. Re-rubric questions, no comment. Like I'm not. I don't have any other rubrics yet. I have some of them in my inbox and I haven't opened them yet because I was playing Puzzle Potluck. Okay, so let's go on. The next problem is the 3D geo, right? Are we doing ISL today? No. I'm basically going through the problems, taking any discussion or question, and then after this I'm going to finish the meta for Puzzle Potluck, because that's almost there. Anyways, okay. Oh jeez. Why are the problem statements so long? Puzzle Potluck, you can Google it. I'll put the URL in the chat actually. It's just like an online puzzle thing, and this year's puzzles were really, really good. It was so, puzzles were so good this year. It was crazy what they pulled off. Where can I find the problems? They're probably on AOPS, but also I am putting them on the screen while we're going through it. Am I doing it solo? No, I'm doing it with like 4 friends of mine. But we're all doing it on and off, so it's not like all 5 of us are working out once. Okay, so let's do USAMO 2. So before I start talking about this problem, I want to talk about the condition in the problem. Like, you know, it's like, okay, I have some beams, you know, they shouldn't overlap, they should fit in the box fine. But then there's this funny condition that, you know, every every beam should like touch something else or something like that. So this third condition, can someone give me some sort of interpretation for it, like a real world interpretation for this condition? This will help me a lot with motivation. So what's an interpretation that will help me for this problem? Connections of each face, like a building. Okay, let me tell you the thing I thought of when I saw this problem, which is that you're like story. You have a box, like you're fitting beams in a box. And the box is like very perfectly rigid. So beams don't rotate, but the beams can fall, right? So what I imagine is, yeah, I have this box and there's beams in it. If I put a beam inside the box, it can't spin at all because, you know, the box is like very tightly fits snugly, but it can slide up and down. And so the condition guarantees that if I rotate the box, the beams don't move around due to gravity. Does that make sense? It's like I have this box and then the condition means that when the beams all have something under them, for example. So the beams don't fall down if I rotate the box in whatever direction I feel like. So that's a way you can think about the problem condition. It's like, oh, you know, it's not a perfect analogy because you can imagine probably like in real life the beams probably would rotate a little bit and you'd be sad. But in this idealized version where the walls of the box are like completely airtight, this is actually the correct condition. If the beams can slide but not rotate, this is the condition to make sure that none of them fall. Yeah. Okay, so how does this help me? I'm going to use this to get the lower bound for the problem. So let's say the beams move in x, y, or z direction. Or so you call them x beams, y beams, or z beams. And then rotate, then look at xy plane or something like that. So you look at the beams in 2 of the directions. What you see is that there is a tower. So unless there are no x or y beams, so let me do it this way. Orient so the z beams are upright, the others are laid down. Then the x beams and y beams what should they do? They like form a staircase, right? In the sense that, you know, on the lowest level there should be, if there's a beam on the lowest level, there's one above it, and then one above it, and then one above it. Maybe this will make more sense if I draw a picture. So let me pull up my iPad. Da-da-da. So the condition is that, because of this condition, when I have these beams in the box, there's always something under them. So if I have a beam that looks like this, then, maybe there's another beam that looks like this, right? So there's a beam that goes like that. But the point is that I should get a tower. So if this is like an X beam and this is a Y beam, say, each layer has a beam. So like tower. So what does that tell me? It tells me that the number of X beams plus the number of Y beams should be at least 2020, unless they're none at all. And so the case where like there's none at all, I'm not going to do anything with. But X and Y should be at least 2020 because you have a tower in the X and Y direction. If I do similar logic, it will tell me it's at least 2020 for Y and Z. And if I repeat the logic again, I'm a little too large. Let me shrink myself. Need to lose some weight. Yeah, nz plus nx is at least 2020. And, when I apply these, I get the bound of 3030. So you get a bound of 3030 by doing this global argument. Once you realize that there's a staircase in each of the three directions, you get this 3030 right away. Yeah. Now, how do I actually construct it? I mean, the construction... I think it's better if I just show you a picture of the construction. So I agree, yeah, so there could be none at all. I did mention, yeah. Unless there are, no beams in one of the directions. Say no X beams at all, but this can be dealt with manually. So I'm not going to do this on stream because anyone that is actually following the solution should probably work that out themselves. And the people that are struggling to keep up, I don't want to distract them with that detail. Yeah, basically, if there's no beams, that's a very easy case. Like, if there's no beams in the X direction, you can just think about what will happen, and you're like, wait, like, you end up having to use a lot of stuff. Okay, so now let me pull up a picture. Oh, jeez, I don't have... Okay. Alright, sorry, one moment please. This is a 3D picture, so it's very hard to typeset. Oh no, did I leave out fragile? No, it... Okay. The staircase visualization is like, basically, if you look at, if there's at least one X beam or at least one Y beam, then what that means is these beams, there has to be one each layer. They sort of, in the equality case, I'll show you the equality case in a moment. It kind of looks like a staircase. And all right, big reveal. That's what the construction looks like. And that's a little hard to see, so I will put the second diagram up as well. So what I meant by staircase is that if you look at the green and blue ones, like they do actually look like a staircase. That's what I mean. You can go from one of the corners of the cube to the other. The two of the corners are paired up in a way that you can go from one to the other. And I'll give you a tiny version of it for... Let me make the top one a tiny bit smaller. Yeah, this picture literally took me like 3 hours to draw. 3? No, it was more like 2. But like, yeah, this is what it looks like. And if you look from the top face, left face, and right face, this is the construction, and it will work. And the way you can think of this construction, I think it's a lot easier to get the lower bound first and then try to construct it rather than the other way around. But as usual, I think other people had it the other way as well. Yeah, you can write an explicit close form, but I mean, I think this picture is just easier to think about. Take at most. Well, most of the time actually was me learning how to use 3D asymptote because I kept running into like compile errors. There was something, yeah, I was doing something wrong. So it took me a while before I could even like start on the work. And then after that, I drew it. Part of the issue is that naturally, by default, there's like lighting on this that makes it very hard to read. So I had to figure out a way to remove all the light from the 3D asymptote. I will eventually post my solution on AOPS, after which you can read the source code to learn what black magic generated that picture. Any questions on this before I go on? This is like, I think the first really substantial solution, so I want to pause here briefly. What level is this? This is a USAMO problem. It's like it's a medium USAMO problem, I would say. Some people want to say it's easy. Like in shortlist, C3, C4 ish. I think it's harder than C2. Mohs rating. I'll know more about the Mohs rating when I see the score. I was going to peg it like 20 or 25. I feel like problems like this where the two directions feel very different are like always scare me a little bit because you can, if you miss one of the directions, you're just really sad. You need to actually get both of them. Also, yeah, 3D stuff is actually quite hard to think about, I think. Would this be rigid? I don't think so. I think this is equality and global. Okay. Alright, if there's no further questions, let me go on to that USAMO 3. Which apparently some people found better solutions than the official one, but... Well, okay. Depends on... Yeah. I think this problem is really like one where like, when I first saw it, I was like, there's no way this is hard. And then I couldn't do it, so I changed my mind. This problem is really cool, the solution. Okay, this one actually has so many equations, it's easier if I go on the whiteboard again. Okay, so, the answer for anyone that doesn't know is 2. The remainder is always 2. How hard was... Okay, fine. Since people are asking, I will say what I have in my database right now, which will definitely change. Because once I start reading student papers, I get a much better idea of what I think the difficulty actually is. But right now I have penciled in 10, 20... I wrote 40, but it really might be more like 45. In a sense, I think the reviewers really struggled with this problem, so... Okay, so here's the idea. We're gonna do some black magic, all right? So A is going to be the set of things that such that A and 4 minus A are both QR. It really looks like it should be easy, right? It looks like one of those like really silly. There's a bunch of problems that look like this that are easy, and then suddenly this one is actually hard. So this is the things that are not QRs. And I'm going to introduce a set B for the things that are QRs. And because of edge cases, I'm going to exclude b equals 0 and b equals 4. I checked to make sure I wasn't taking JMO. Well, it does look easy. So note that, okay. So what I'm going to do is I'm going to, rather than calculate product of A, I'm going to calculate product of B, or at least I'm going to try. So go in B. This is the same as the product of 4 minus B, because, an element's in little b if and only if it's in 4 minus little b. And when I do that, well, these are quadratic residues, so I can factor this and write 4 minus y squared, and now I have to be careful. So this is a cross 1 between y, between p minus 1 over hat 2, such that y is not 2, and 4 minus y squared is not a QR. So there's like this constricted set of y that work, and it looks like 4 minus y squared. And when I do that, I mean 4 minus y squared obviously factors. So let's factor it. 2 minus y, 2 plus y. Okay, and now that it's factored, I want to actually get rid of the minus sign. So I'm going to change this. So the second thing will be the same. This will be 1 from y. So again, you go over all the squares other than 2 squared, such that 4 minus y squared is QR. That's 2 plus y. For 2 minus y, I'm going to flip the sign, and now my sum will run over the negatives of those. So this is p plus 1 over 2, up to y, up to p minus 1, such that y is not p minus 2, so that the product is non-zero, and 4 minus y squared is QR. And when I do this, now I can put them together, right? These two things fit together. And so you put the giant subscripts together, and now what I have is this product from y, which is not 2 or p minus 2, such that 4 minus y squared is not a QR. I guess y should be not 0 as well. Yeah, and of 2 plus y. Okay, so wow, that's a really big subscript. We're gonna shift it now so that it's a little cleaner, right? So let's shift it so that it becomes, let z equals y plus 2, then a bunch of stuff cleans up. Now what I have is z, 0 from z to p minus 1. Well, okay, just all z that are not 0, 4, and 2. I'm just shifting. And I want z times 4 minus z to be a QR. Should these be product over y such that 4 minus y squared is a non-QR? No, it is QR because this is the product of b, not a. So it's very strange. I start the problem by saying I'm going to ignore the thing that I'm actually going after and go after the product of b instead. It's sort of the problem with the word not deleted is what I have here. Okay, well, what are the numbers such that z times 4 minus z is a QR flipped across different sums? Did I flip a sign? Which sign did I flip? Sometimes say QR and not QR. Oh, okay, yeah, sorry. I don't know why I wrote not anywhere. This is just erase all the notes. Yeah, it should always be QR because I'm computing over B. Shout out to Evan Chen from O1, V1, E1, R1, L1, O1, R20. Yeah, sorry, they should all say is QR. Okay, so now for the really tricky bit. This product here is equal to the product of z for z in A union B, z not equal to 0 to 4. Because A union B is exactly the set of things yeah, is exactly the set of things such that z times 4 minus z is a quadratic residue. Yeah, it's very... It's kind of ridiculous. Like, I have no idea... This was the official solution. Somehow. Okay, so now that I have this, this is equal to like, because of the 2, it's equal to 1/2 of just z and z union a cup b. And then you cancel, and you get product of a is 2. All right, and that concludes all the problems from day 1. Okay, any questions on day 1? Oops. Oh, crap. I untimed out the wrong person. Oh. This is so... I really don't like this interface. How do I untime out? Okay. Yeah, I was trying to time out the BizWood dev person, and then I accidentally timed you out instead because the chat scrolled and I hit the wrong timeout button. I apologize for the accidental timeout. But we can't have a number a such that a is a QR but 4 minus a is a QR? I don't understand. Like, a and b are two specifically defined sets. There are numbers of the form that you mentioned, but they're not... They just don't appear in this problem, period. Okay, so by popular request, I am now apparently supposed to take... Can I explain moving points? I'm trying to write up a blog post about it. Wait for that, I think. It won't make sense over stream, I think. Alright, so 2 ad breaks. Yeah. Yeah. It's great to be immune to Twitch Prime, huh? To the ads, yeah. When is that blog post going to be ready? I'm not sure, honestly. Yeah. Okay, so let's go to day 2. Okay, so JMO4 is a geo, right? Angle chasing geo. So, I mean, the angle chasing geo is literally an angle chasing geo. You can just angle chase it like in multiple ways. It's not a particularly, it's not like a trivial one. It's like, it's a chapter 1 problem, but it's not one of the easier chapter 1 problems relative to EGNO, I would say. So for instructiveness reasons, I'm going to present the super highbrow solution. Just because it's funny. But I expect most people to do some form of angle chase. Okay, so I'm gonna start by doing the following, just to show you that is it known that a graph without k4 or k23 has at most 2n minus 3 edges? That sounds like it should definitely be false. Like, just take like take any. It's true? No way, right? Without k4 or k23? Oh, planar. Okay, then I don't know. That's probably true. Or actually, I'm not sure. Let me not talk about things I'm not sure about. So we're going to replace E with the point on line, it's like CD, such that E, I'm going to mess this up. Let me check my notes. EA equals EC. And then I'm going to drop a condition, which is that I'm going to drop the AB equals BC condition. So I'm doing this thing because I suspect a lot of people have like one argument or another for this problem, and I want to show the maximally general one. Freaking, I'm so used to pressing that button. Alright, sorry for the technical issues. So, there's the diagram. I hope. That's the wrong diagram. No. One day I'll figure out how to use this computer. That day is not today. What app do you use? I'll make a chat command that says that actually. So the one I'm using for the typeset diagrams is Asymptote, but I also use GeoGebra, and the whiteboard is Miro. Okay, so basically what's gonna happen is, I'm gonna replace E with this point here, and if I do that, I claim the problem is true even without BA equals BC. So the problem is actually way more general than it gets credit for. The reason it's given in this particular form is that in the form that you saw on the actual JMO, there are some approaches that work that don't work in this case. Namely, F is like the center of a certain circle. Okay, now how do I do this version? One answer is that you can just write angle chase. So I'll show you the angle chase, I guess, because I want to pretend that I'm being instructive. No, this is Milan-Hyman's problem. So first, Reims theorem. Let me not call it that. So AFVD is cyclic because DEF equals DCB equals DAF. So that red guy is cyclic. And then you can do the following angle chase. Angle FDB, this directed angle. Let's just push it all the way through. So it's equal to FDC minus BDC. And I can copy those angles, and that's FAE minus FAC. And that's equal to CAE. So what I got is I managed to take FDB, do the subtraction, and then copied it until it was equal to CAE. That's this green angle here. Well, if it's equal to CAE, then it's equal to ECA, and it's equal to DBA. So FD equals FB, QED. So this is a complete proof of the JMO problem. Two lines angle chase for the even general version. There were no configuration issues. I think the side lengths will get rid of all the configuration issues. Like we specified that DA is less than AB equals BC less than CD to basically make sure there was only one way the picture looked. Yeah, so you're welcome is the short version. Yeah, now I will comment one quick thing, which is that if you want to see how to overkill a JMO for Geo, you can do the following. Actually, do I want to present the solution? No, actually, I'm not gonna. Do you guys want to see the Pascal solution? I don't know if it's like worth my time to do it here rather than just post it later. Please present. Okay. All right. I'll show you the Pascal solution. All right, one moment, please, while I put up the new diagram. Okay, so here's the overkill solution. So define G and H by extending those things, all right? And the reason we extend G and H like this is because, thank you, Jackie Puppet, for the follow. Well, you get one isosceles trapezoid here because of the EA is equal to EC. And if FD is equal to FB, which is what we hope, then we should get another parallel thing. So we know ADGC is isosceles trap, and we want DAHB to be isosceles trapezoid. Okay, so now I'm going to do two things. One is I'm going to use Pascal's theorem on GDC BA, GDC BAH. And when I use Pascal's theorem there, what happens, it tells you E, F, and GH intersect BC are collinear, which is pretty good because GH over, you know EF is parallel to BC, so at this point you know thus EF, GH, BC are pairwise parallel. And once you know they're pairwise parallel, you get the arcs have equal length. So this arc is now equal to that arc, so it's an isosceles trapezoid. So measure AD equals measure GC equals measure HB. I am embarrassed to admit this was when I was told the general version was true, I found this solution before I found the angle chasing solution. And the reason is that I don't know. I have an affinity for trying to get rid of Euclidean conditions because I think projective geometry is easier than synthetic geometry in some sense. Like once you get used to it, if a projective statement is true, there are fewer things to try. So that's a reason why once you are familiar with projective geometry, it's actually better to make things more projective when you can. Thanks to MLG Jeff Dogue 21 for the cheer. 1 bit. Yeah, and so when I saw there were all these isosceles trapezoids, I was like, okay, well I can now the EA equals EC and the FT equals FB conditions are both tell me something about parallel lines. And after that, I was able to translate the problem in this way. So that's how you can throw a Pascal at this if you really want to overshoot it. Okay, let's go on. So next on the menu is USAMO 2024. How do you know this can be done with Pascal? How else do you deal with E and F? I guess is my question. Like I saw there was something about EF being parallel. Why not first use angle chase? I don't know. I saw E and F and I was like, this feels like a Pascal thing because the condition I want is equivalent to EF, GH, BC being pairwise parallel. And so when I saw that, I was like, okay, well, E and F are both intersection points of diagonals in a cyclic thingy. So throw Pascal at it, see what happens, and then it worked. He should write a book or something. Definitely haven't had that idea before. All right, cool. Let's do USAMO 4. USAMO 4 is an interesting problem because this is the problem that is arguably all of ACGN. Like it's clear why AC and N are here, but let me explain why this actually has some geometric idea in it. What is this determinant? This determinant is like the area of a certain triangle. How's it A? I mean, it's a problem about like a determinant. So yeah, what this condition is saying is that you want two triangles with, sorry, not triangle, 2 points are friendly with each other if the area between them is actually exactly 1/2. So that's what the condition says. Okay, great. Now, so what I'm going to do is claim farthest point has at most 2 friendly. Oh, I guess the word friendly is not in the problem. So let's say 2 points are friendly if their area is 1/2. You know, they're like close to each other. Well, we'll call them friendly. That'll make this a little easier to talk about. So I claim the farthest point has at most 2 friendly things. And by farthest, I mean like Euclidean. I really mean Euclidean distance, although other distances work as well. And the reason is if I have a point here, you know, this is far. So everything else lies inside big circle. So if I have a point that's friendly here, above it, well, where's the next one? If this is friendly, the next one is going to be all the way out here. Because the fact that it's in a friendly thing, any point that's in any friendly triple at all requires coordinates, the x and y coordinate, to be relatively prime. You can see this either by Pick's theorem or just by looking at the expression AD minus BC. So if I have a friendly guy here, the next one is out here. And also there's one here, and like the next one is out here. So if there's a friendly point, the reflection is also friendly. If I have a point, if I have one friendly guy, this guy is also friendly. It should be on the orange line. Sorry, that's just me drawing poorly. However, the next friendly points are all outside the quarter circle. So this means that, therefore, at most 2. Or just look at the picture. So once you have the geometric picture, then the problem, you know, you keep deleting things up until you have delete until at most 3 points, then 3, then at most 3 friendly pairs. So you get a bound of 2n minus 3. Basically, you'll get a bound of the form 2n plus something because you lose at most 2 pairs by deleting the upper point. And equality can occur in several ways. I'll just draw one example of an equality case. Done. Actually, let me make sure I get this right. So let me check my notes. Yeah, so yeah, this is an equality case. This gets 2n minus 3. The end. What do you think the easiest USAMO after 2000 is? Go on my website, find the Mohs ratings, and then look for the one that looks easiest. It's better that you look at the full data rather than try to get an aggregate. Not 2020. 2011 might be a good candidate. Actually, 2012 might be a better candidate. I'm not sure, but no, definitely not this year. So yeah, it's really cool because like you don't need to use the geometry to get the claim. Like you can write out the algebra. But I think if you look at the geometric picture, then it becomes much more clear that this is the right way to go. It's the points that are far out will, you know, make the other things go even farther. Yeah. And so this is a problem that is a wild card. Like you can argue it's any of the 4 Olympiad categories, which is great. Okay, let's go on to the JMO 6. Okay. So JMO 6 is a problem about, this is the abridged version that's like at least readable. It's like I want, if a polynomial vanishes at whenever any 2 of its arguments are equal, show that it has at least n factorial terms. You can actually figure out what the equality cases are. They're called the Vandermonde determinants. So for n equals 1, there's equality at x minus 1, x minus 2, and then frick. Whatever, I won't bother expanding it. So these are what the equality cases look like, and in fact, you might already know that you don't need it. You don't actually need any of the Vandermonde stuff, but you might already know that these happen to be the correct ones. Okay, so how does the idea of the proof go? I'm going to, let me decide how I want to do this. Okay, so I'm going to do the following. Big claim. Big claim. So no term of P is missing both xi and xj. Like when I look at, okay, I'll expand the top one. Like if I look at this thing, you know, this is x1 squared, x2, minus plus x1 squared, x3, x2 squared, x3, plus x3 squared, x1, plus x1 squared, x2, minus minus, da, da, da. Yeah, like when you look in here, for example, so, you know, every monomial is missing one of the variables, but none of them are missing 2 of them. What's the proof of this claim? It's actually quite straightforward. Proof, if not, then set xi equals, how did this go? Yeah, xi equals xj equals 0, and x1, all the others to whatever you want. And when I set xi equals xj equals 0, you know, there's some term that's left over that doesn't get canceled out, so it can be anything you want. So there's no way the polynomial is always 0 afterwards. Is that okay? All right, so now, well, you can look at the things that are if I have this claim, I can look at, you can start plugging in 0. So I want to look at, for example, p of 0, x2, dot, 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 xn. And there's two cases. Let me put this in different colors so it's clear it's not part of the previous proof. So what happens? This polynomial could be equal to 0. If this polynomial is identically equal to 0, that means x1 divides p. So, okay, well that's silly. If if x1 divides p, I just divide it out. So I don't have to think about this case. The other case is that, okay, well I set this equal to 0. Let me pan a little bit. The other more interesting case is, if not, it also has the property that whenever I set any two of its arguments equal to 0, the whole polynomial vanishes. So it has at least n minus 1 factorial terms if I'm willing to induct. So yeah, there's at least n minus 1 factorial terms here. And similarly, some people, I guess, can already see where this is going. P of x1, 0, x2, 3 has at least n minus 1 factorial terms, and so on, where, yeah, and because of the big claim that no term is missing both xi and xj, all of these terms are distinct, like you won't get any repeats. So in total, at least n factorial terms. And that completes the induction. When will you change the stream's name to reflect Radiat Chatter's request? Is there a new request? Oh, there's a bunch of shoutouts. Shout out to On the Spot Stem from Dennis Chen. Shout out to MLG Jeff Dogue 21. And shout out to Brian ZJK from Bra4D6N. Okay, two more problems, right? Two more. This is pretty easy for a J6. I think I already changed the stream title for dotted calculator. It should be there already. I will say something to be very clear for the record. I actually didn't solve this when I was test solving this problem. Granted, I have a whole package to work on, so I don't spend that much time per problem, but I couldn't figure out how to do it in the time I spent on it. So yeah, I don't think this is I think this is fine for J6. Like, I think on the JMO, it's good if there's like a problem that I don't solve, and for me, it was this one. Maybe it's not good, actually. I don't know. I think it's a case where the solution is short enough. Like, it's not like this long technical solution. Or it can be, but it doesn't have to be. So in math contest, there's this thing called, that's sort of like the infinite monkey theorem, where if you have enough contestants and the solution is sufficiently short, then, you know, someone will get it. Someone will get it. Oh, did I miss a shout out to Grant Yu? Shout out to Grant Yu. Sorry I missed it. I guess it didn't show up in the rewards queue. All right, let's talk about overdetermined sets. Okay, so this is a problem which is not geometry, even though I know some of you will go and say that it's a geometry problem. Let me talk a bit about it. So you're looking for these overdetermined sets, You want to maximize them. So let me say a bit about polynomials. I mean, you may or may not know that if I have, like, for example, in general, if I have d plus 1 points, there is a polynomial of degree at most d passing through them. So for example, you know, if I have 3 random points, e.g., 3 random points determine a parabola. By Lagrange interpolation. Now, I say parabola, and I really should put parabola in quotes because, it could be a slightly smaller degree, and that's where overdetermined comes in. If I have, for example, 3 points, and these points are collinear, thanks to Toku 1996 for the follow. If these points are collinear, I get a degree 1 polynomial through them. So this is an example of an overdetermined set. Alright, that's one overdetermined set. Now I want to point something out, which is that, I have these 3 points. Suppose I have like another 3 points, 2 of which are this one, and, a line through them like that. Like an overdetermined set like this. Well, something's wrong with this picture, right? What's wrong with the picture? Everything. Yeah, like the problem is I have these 2 lines, but yeah, they don't intersect twice. Like, what is this? Like, if I had this point, and a third point, these blue points, actually this blue point really better lie on this line. So what that means is if I have these overdetermined sets that intersect like this whole thing should be overdetermined. Right? Because otherwise this picture is really messed up. And now let me say something more general, which you can prove in exactly the same way. Claim if t intersect x and t intersect, well, not intersect. If t union x and t union y are both overdetermined, then so is t union xy. Right? If I have two overdetermined sets that overlap, like mostly overlap like this, then when I put them together, the intersection is also overdetermined. Great. This claim is all I'm going to use about polynomials. After this point, I'm going to treat it purely as a combo problem. Yeah, you do not need any more. You can use more polynomial things. There are solutions that prove more claims that make the combo easier. But I'm not going to use any of them. I'm just going to stop here and say, what's going on? So let me draw like a picture. You can now imagine, I wrote it this way, but I'm actually going to talk about this other thing. So we're going to say a set is flooded if it is not overdetermined. So we want to minimize the number of flooded cells. In my original write-up, I actually called these infected subsets, but that was back in like October. And given current situations, I decided it might be bad taste to continue using infected. So they are now flooded. Then the claim is saying any flooded set has at least one flooded subset. Sorry, wait, that's wrong. What did I want? Has at least. Is it at least one non? Okay, let me get this right. Has at most one non-flooded set. Sorry, that's what I meant. So overdetermined, but I want to think about it in terms of flooding because I find that way more natural. Because what's this flooding argument doing? It's telling me that let me draw a really big Haas diagram. So here's 1, 2, 3, 4, and you're given that this 1, 2, 3, 4 is flooded. Okay, yeah, there's a flood. It's not great. And this 1, 2, 3, 4 has some subsets. 1, 2, 3, 2, 3, 4, 3, 4, 1, 4, 1, 2. And then there's more subsets, 1, 2, 2, 3, 3, 4, 4, 1, 1, 3, 2, 4. 3, 4, 2, 3, 3, 4, 2, 4. Pew, shoo, 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 shoo. Yeah, whatever. And then 1, 2, 3, 4, and I guess there's one element sets, although we don't really deal with that. Why are you using non-flooded? Because I actually want to forget the word overdetermined and think about it in terms of flooding. Because it's just more natural this way, I think. Because what it means is I have this 1, 2, 3, 4 at the top, and it's flooded. So that means all of its children, almost all of its children are flooded. So you can imagine it's like I have this flood, and this flood is going down, like being pulled down by gravity. There's like, there's this flood that's going down. And you kind of want to avoid having too much flood. But you have a constraint that whenever a cell is flooded, there's a flood here, so I can get it out of, say, 412, so make sure that 412 is not flooded. Actually, let me do 1, 2, 3. I can like save 1, 2, 3, but then the flood spreads to these 3 cells, right? So this one is saved. All right, saved. And now all of these guys have to have at least one flooded thing. So this is one example, for example. I can save these 3 cells and be okay. And the flood propagates down like this. Okay, once I have this, I can do the following. Claim, subset 1 level down. That's what I meant. So like, direct descendant. Let me just write descendant because it's more natural that way. Okay, so then what I claim is that main claim at the kth level, at most, so at least, let me get this right. n-1, choose k-1, flooded. Where I'm indexing from the top, so the first level is k equals 1, the next level is k equals 2. And why is this the case? The idea is that I can double count. So first of all, I guess at this point I should say what the equality case is. You can see that there's an equality case. This example is called flood everyone with 4. That's sort of the tight example, and it will give you some answer. And my claim is that that's actually best possible. What's the reason? So suppose I'm at level k, and you're going down to k plus 1. So you know there's at least n choose k on n-1 choose k-1 on level k. n-1 k-1 on level k. And on level k, you go down and there's each one of these sets. For example, in this case, k equals 2, and each of these guys has at least 2 flooded neighbors, or descendants. So this is the number of descendants per flooded. But you get some double counting. For example, this 2, 3, 4 and this 3, 4 both flood 3, 4. And the maximum number is n-k-1. So this is max accepted. So for example, this 3, 4 accepts 2 floods. Okay. You have that. Let's write what this is. Oh, look. It's n minus 1, choose k minus 2. Let me write that somewhere else. And that completes the induction. And shows that my equality case where I flood all the cells that contain one particular element is best possible. Is there a way of highlighting a message without V-Bucks? No, I don't think so. So after that, you can just extract the answer. I think it's like 2 to the n minus 1 minus n or something like that. But this is the claim. It's like, I have this flooding property. The polynomial is only used a little bit here in order to tell me that a flooded set is mostly flooded below it too. And now I think of it as a combo problem where this water is spilling in from the top. And it turns out the double counting argument simply works. That's true. You can highlight my name, but it doesn't highlight the message. Why was day 2 CCC? Is problem 6? Like, see, you say that, but someone else was complaining to me, why is day 2 AAA? So, shrug. They're all hybrid problems, so you can do whatever you want. See, there you go. Day 2 is both AAA and CCC, and it's also like, I don't know. Yeah, whatever. Okay, one more problem and then I can retire. So for this problem, I'm actually going to go after the... Do I want to do this on a board or not? I'm gonna do this on the PDF. Okay, so here's the problem. It's an n variable inequality, which I'm still upset that I fake solved this problem because I think if I hadn't messed up, I would have solved it. But can't just make excuses like that, right? I messed up. Okay, so this problem, I have heard of make King of Ghidorah superstar. This problem might look a little familiar to some people. And the reason it might look a little bit familiar is because then there's another USAMO 6 that also involves numbers that have sum 0 and square 1. It looks like that. From there. And I didn't make this connection, but it has since been pointed out to me that these problems are actually quite connected. So that happened. So if you've seen the 2012-6 before, that will help you a little bit. If not, I'm not going to use it anyways, so it's fine. So for the people that haven't seen the solution, first of all, you have this sorting and this like subtraction thing, and you might recognize, okay, well, what I'm going to do is I'm going to say for a permutation sigma on 1 through n, I'm going to define s sub sigma to be equal to sum xi y sigma I. And what rearrangement tells you is, rearrangement inequality doesn't help you very much, but it does tell you like the only bit you need to know. It says the sum xi yi is the biggest one, and the other one is the smallest one. So in some sense, the left-hand side is as good as you can get. Like by as good as you can get, it's as favoring you as you can get because the left guy is the biggest one possible, and the right, the thing you're subtracting, is as small as possible. So this inequality is saying a statement about s, the distance between the biggest and the smallest s sub sigma. Yeah, so we're going to go after the variance. Before I do that, I want to first construct the equality case. And let me pull this from my notes so I don't get it wrong. So the equality case is the following. And this non-standard equality case means that you can't just like cheese the problem using AMGM or whatever. It looks like that. So that's how you get 2 over root n minus 1. I think this only works for even n. I want to say there's no equality case for odd n. I'm missing a comma, aren't I? I keep typing USAMO instead of USAMO. It's not great. And what you notice about this is that when I have USAMO, yes, USAMO was harder than USAMO for sure. I think. Or at least at the hard end, right? Like, I think, okay, let me be a little more precise. USAMO 3 and 6, I think, are harder than USAMO 3 and 6. But 1 and 4 on USAMO were maybe easier than the corresponding USAMO problems. Can you please upload? Yes, this will be on YouTube for sure, because it's the USAMO review, so people will want to look at that. Right, what was I saying? If you look at this equality case, it has the property that S sub sigma, like half the S sigmas are 1 over square root n minus 1, and the other half are S minus 1 over square root n minus 1. Okay, so let's use this for a proof. The idea is we're going to do two things. One is that I'm going to look at the variance. So the expected value of S sigma is equal to 0, because when I sum it, you get like the sum of xi times the expected value of the yi. The y's have average 0, so this whole average is equal to 0. Okay, what about the expected value of S sigma squared? If I look at S sigma squared, well, you get what? Sum of I xi squared times expected variance of y. Which I... And then plus, thanks silicon salad for the follow, the sum of I less than j of 2 I xi xj and then expected y sigma I expected y sigma j. Or sorry, no, that is not correct. The y sigma j should go inside. So basically what I'm doing is I'm looking at the expected value of S sigma and S sigma squared. One reason you might want to think about squares is because, well, the answer has a square root in it, so you have to square it at some point. Okay, and you can compute this, and it turns out, I'll just spare you the work. It works out to 1 over n and... ah, freak. 1 over n minus 1? No, just 1 over n minus 1. Right, okay. So that's great. I have a variable. What does that variable look like? It's like, we think the best situation is when it's like oscillates between plus 1 over root n minus 1 and then minus 1 over root n minus 1. That's sort of like the best case scenario. And in fact, you can prove that. Claim variance of 0, 1 at most a quarter. Here is the claim. So we're going to say let A be a random variable with values between, let's say, minus You have a random variable and it's oscillating between somewhere. And the average is mu. Then the variance of A, which is the expected value, how far can A be from mu squared? This is less than or equal to m minus m all squared over 4. And the stereotypical case is that if I have a random variable with 0, 1, and I want its variance to be as big as possible, that happens if I have always 0 or always 1 with a coin flip, and that will give you a variance of 1/4. Can you give me a hint on USAMO 2012-6? Square everything. Just square everything. Okay, if you want a proof of this, I will prove it for you. By shifting without a loss of generality, m equals 0, m equals 1, then e of a minus mu squared. Well, what is it equal to? It's like expected value of a squared minus mu squared. And because it's in 0, 1, a squared is less than or equal to a. So, okay, well, this is equal to mu minus mu squared. This is less than or equal to 1/4 by maximizing the quadratic. Running a little bit out of space. There we go. So that's the proof of this. And now I can apply this to this problem because the S sigma, I wanted how big the interval was. For Geico Lizard, yes, and you just work around it by using the fact that some of them that their mean is 0. So you can take complements. Where was I? Okay, so now I just apply it verbatim to this problem. Like I have this thing where I know the mean is 0. And I know the variance is 1 over n minus 1. And I know that max minus min squared is at least this number. So what that means, I'll just put this on the left so it fits. It means max minus min squared over 4 is greater than or equal to the thing we have, 1 over n minus 1. And as I said, the max is... Oh, shit. Yeah, the max is sum xi, yi, and the min is xi, y, n plus 1 minus I. And that does it. So I think the main motivation is that when you realize that in the inequality case, like if you look at other permutations, not just like the biggest and the smallest one, well, it turns out that actually it's a random variable where top and, you oscillate between the top and bottom randomly. Just plus 1 over root n minus 1 and minus 1 over root n minus 1. And once you realize that, you can use this type of argument, which I think is related to like Chebyshev type things. Geico Lizard, square everything and take expected value. Okay, we did it. That is all 10 problems on this exam. %40% of I got this because I did use some 20 tools. A lot of people went and told me that. They were like, hey, this problem, like, thanks for showing me USAMO 2012-6 because it let me solve this problem. And I'm like, what are you talking about? And then they showed me the solution, and I was like, oh, okay, I see. Because it did not occur to me to look at the random variable. My idea for the solution was to try to show that in the optimal case, x's take at most 2 values, and so do y's. And if you can do that, then the problem you can just verify directly. And there is a solution that does that using convexity. Yes, the editor is Vim. I don't know. My guess might be no, because the reason non-zero is there is because we wanted to not define the degree of the zero polynomial, which should be minus infinity, but like it takes up space. So it was easiest to just cut out the zero polynomial from discussion. So yeah. What was day 2 on Mo's? So in my notes right now, I have 20, 30, 35, and it will probably change once I see what the actual scores are. I do actually think USAMO 5 is not easy. Like I don't think the Overdetermined is a USAMO 1, and in fact I know some people who thought it could be like a USAMO 3, an easy USAMO 3. What do you recommend to learn method of moving points? Honestly, I just need to write up that blog post. Is a short answer. I put the USAMO 3 at 45, but it sounds like people found it easier than that. Yeah, like my ratings are always way off until after I actually see the scores, because like it's I can give a good rating once I have my own personal experience, so I know the problem well, and then also see what the students did on it. That's part of why I don't release most ratings for like, I only release most ratings for like problems I quote unquote know well. Like it needs to be problems for which I have, I guess it's not true for the old USAMO, but when possible, I want to have the actual stats. Even better, I want to have graded the problem, and I definitely want to have done it. Are you going to put these in problems into Otis units? Yeah, obviously. When I get new problems, I add them in. But there's a lot of good ones, right? Like, I want to put them in Otis so I can show them to people. What? Alright. Awesome. So... No, they do not average. Oh my god, that's not how grading works. The way USAMO grading works is that you have like every problem is read by like at least 2 graders, and if they agree on a score, then that's the preliminary score. And if they don't agree on this score, then they argue about it / bring in more graders until they agree on a score. Nothing is done by averaging. Yeah, so they grade the first batch of papers this way, and then usually the top 25% of papers or so then get regraded again. Yeah, no, it's not averaging thing. That's not. No, it's so bad. We're not the SAT. Isn't it kind of average then? I mean, no. What happens is if the graders don't agree, then one of two things happen. One is that one of the graders made a mistake, they misinterpreted something, or they thought something didn't worked when it didn't, or they don't agree on the rubric, and in that case, more people get involved because that means the rubric needs to change. Yeah, like if there's a discrepancy, it either means that one of the graders made a mistake and then they'll fix the mistake. That's what double grading is for, or they agree on the math but they don't agree on how much it's worth. And in the latter case, then you have to bring in the problem captain and people will make a decision. And that's why there's a problem captain, so that all the quote-unquote hard cases go through one person to make sure they're consistent. Do things like Turon's theorem? I don't remember seeing Turon on USAMO. I've seen it on TSTSD. I'm not sure. Okay. Alrighty. USAMO rubrics emulate USAMO rubrics to some extent. I mean, they emulate it in the sense that it's like kind of the same crowd of people, and USAMO rubrics and USAMO rubrics both mimic a thing, which is like what USA standards, whatever those are, which isn't written down anywhere as far as I really know. So, you I will say I think this year's USAMO rubrics, like for the USAMO that just happened, were unusually harsh. I was quite surprised when I saw, for example, mostly the two rubric. I was very surprised by. I think I was like, oh, you know, I wanted to give a point for the answer, but the problem captain and the author both said they didn't think it was worth a point. So I was like, okay, fine. Because I don't know, I feel like random polynomial with no roots times p plus minus x plus constant is a non-trivial enough answer. It should be worth something. But admittedly, it doesn't really help you solve the problem that much, I guess. Or in a sense, you can write down the answer without having any clue how to actually solve the problem. So that's the argument. It shouldn't be worth anything. Hey, 1, 2, 3, 4, 5, we're all really? You guys think that USAMO is that easy? I was worried this test was too hard, I'll be honest. I was like, I got 1, 2, 4, 5, but I feel like I barely got 2 and I barely got 5. Oh, okay, wow. I guess the kids are just better than me now. Seriously, 20 sweeps? Okay. I'm glad that we don't have big prize money to split this year. Oh, 20 sweeps day 1. Okay, that I believe. I was like, 20 sweeps on the whole test, I feel very surprised. 20 sweeps day 1, I think. Yeah, day 1, I definitely believe 20 sweeps. That's fine. Like, I think 20 people sweeping day 1 is okay. Yeah, because I think there's probably like not prize money this year because of, you know, obvious online constraints. Yeah, I think day 2 was harder than day 1 for sure. I think day 1 I wasn't worried about. I was mostly worried that day 2 might like... I was worried day 2 might be too hard, and then I found out about the variant solution to problem 6, and I was like, okay, now I'm not that worried anymore. Part of the reason also is because USAMO 6 is an n-variable inequality, and I feel like it's a topic that like people just have forgotten everything about how to do. Like it's sort of like, well, you know, I think it's a weak spot, just algebra type things. So yeah, that's part of the reason I was like, yeah, I like this choice of problem because I think it's something that it's something I want to test the students on because it's not something that they've been studying enough. Yeah, cyclic quads are common because they're useful. It's a short like basically the problem is that if you don't without cyclic quads, your angle chases are very limited. Like you can only use you basically only use the fact that stuff triangle angles add up to 180 and you just can't get very far with that. So like anytime you have like non-trivial angle chasing, you probably have to have a cyclic quad. Like you can't do it without that concept. I pronounce it Cauchy, Jensen, and cyclic to answer that questions. Brian Con. I hear cyclic every so often, which honestly sounds cooler, but I'm not used to it. Let's call it. What is the hardest single chase ever? I have to think about that. I'm sure there's some somewhere, but I don't know what they are. How do you pronounce the first vowel in economics? Like E? Oh, I see. Yeah, that Iranti of 2010 one. It was quite a bit. That's your solution? I don't know what Erdo's co-radio is. Let me look it up, I guess. Oh, huh. I bet it does, now that I'm looking at this theorem. Like, it's the same bound. And I see the same calculation happening. So yeah, I think there probably is a relation. I won't say too much because I don't know enough. But I would look into it. I would bet there's something. At most, how much do you think I can improve in 1 year? I mean, it's possible to go from like nothing to mop in a year apparently. So lots of things are possible. How do you filter out the rest of your room? I have a green screen behind me. So yeah, I have a physical green screen. Could you add your Vim setup to GitHub? It should be under dot files. Like if you look at my dot files, you can see my Vim RC and stuff. Yeah, I think it's just, yeah, I don't know. Stream delay, yeah. I don't know, computers, they do something somehow. Alright, wow, I have a lot of viewers. Did you get your own domain for evanchen.cc? Yeah, it's a Google domain and it points to a Google static server. What is your favorite field in math? And I think it's actually number theory. The real number theory. Unfortunately, there's not that much to go around. Why is your username venhance? It's just an anagram. Like it was 2010 and I was registering for this AOP site that I had just learned about, and they were like, don't use your real name as your username, and I was like, okay. So then I took out a Scrabble set and spelled out my name and then shuffled it until I got something I liked. And that was my username. Will you play Braid or Baba as you? After whatever you were gonna finish. Probably not now. I think. So here's a problem I have. I need to grade the USAMO tomorrow, so I don't want to stay up too late, because yeah, it might not be good if I am sleep deprived when grading the USAMO. We'll play some Braid. We'll play some Braid on Friday. How about that? Can you change my AOPS username for me? No, I'm not an admin. I'm just a mod. So all I can do is like delete posts and log threads and contests and programs, and that's about it. When are results expected? Next week, maybe? I don't know. Honestly, like, the grading takes a while, but then like sending out the results apparently just takes a while too. It might be faster this year because everything's on AOPS, so you'll just get your score through the account you registered on. Um, can you add the usage MO? Oh. Someone else please give me a collection and I'll add it. I hate using the interface. I've been told I have no chance at improving from low JMO to good AMO in 1 year. I just told you can go from like nothing to MOP, so like I think that's definitely not true. Like I'm not gonna. It's really hard for me to comment on questions of the forum. Like, is there a chance? Because the answer is basically always like yes, but that doesn't help. Like I can say yes, it doesn't do anything. Like yes, it's possible. What else do you want me to say? Kind of thing, right? Did you feel when you were improving? I think there were moments where I noticed, like for example, like a problem that I would really like had a tough time with. Like I would come back to it. I'm like, oh, this isn't so bad. I feel like I know what's going on now. And like I'd like see a test and then later, oh, I haven't told it. Okay, well, if you want the answer is the probability is not zero. Like it's possible, but like yeah, like it's possible. Just I know what you want me to say. Like yes, it's possible. What is the most amount of time you think someone should spend on a math all day? Um, I think that really depends on the person, I would say. I think probably individual people probably have a limit on how much they can do in 1 day before they just get too tired to like make much progress, but I doubt that limit is uniform across people. Also, average is probably a better metric than max. Like, there's definitely days where I just did math for like 9-10 hours, but I certainly couldn't do that every day. Yeah, there you go. Alright. I mean the average will also just be different from person to person. Like I don't want to say a number because the standard deviation might be about as large as the mean. I have this problem a lot actually, where people ask me for like the mean of some distribution and I don't want to tell them because the standard deviation is so large that the mean is not useful to know. Alright, cool. Alright. Okay, yeah, I think that's probably about all I have to say for today though. Thanks for coming out, and hope you guys enjoyed watching the solutions. Yeah, it's just a short day because it's not the Friday stream. Placing them, please. On Friday, I wanna finish the puzzle potluck and then go to sleep so that I don't die tomorrow because I have to grade all day for like 3 days. Can you stream the puzzles? I'm not sure I should because the puzzle hunt's still ongoing. Can you refund my V-Bucks? What did you request? He requested a problem? Oh, sorry. Yeah, let me refund that. What team are you on for potluck? Just like, it's the team that says like Vevin and Jevin or something like that. Yeah, I don't. They might be done by now, actually. I'm not sure. We were like very close to done, and then I was like, shoot, I have to go run. I don't know. It's just a random string. Don't worry about it. What did you get your PhD in? I am a current PhD student in math. I haven't got to my PhD yet. Please stream puzzles. I might stream. If you guys are interested, I can stream mystery hunt puzzles just for fun. As in, like, I've been considering doing a thing where, like, for the quote-unquote game, we just like do mystery hunt puzzles, and yeah, on stream, and I have a spreadsheet. Stream USAMO grading? No, definitely no. What did I get my master's in? I didn't get a master's degree. How many hours of games did you play in high school? Not very much. I mean, it came in pieces. Like, I played some. There was a while where I played a lot of like StarCraft 1. But I didn't on average play that much because I just like did math instead. Like it was about as fun and more. It was slightly less fun but more rewarding long term. So I ended up doing a lot more math than video games. Once you start playing chess, you stop playing all video games. Is that so? Reverse. Oh my god, is there a chess game happening in the chat? I think I'd find chess a lot more fun if I like took the time to actually learn some of the standard theory, so that because most like for me when I play chess, like the first 30 moves, I don't even really know them. I'm just like, I'm supposed to do a move, and I know that there's a standard move I'm supposed to do probably, but I have no idea what it is. And so, you know, just kind of pick one. All right, okay. Anyways, yeah. Yeah, that's all for today, and thanks to the Prime sub for today. Let me find the... Yeah, xtile0 for the sub. Alright, good night all. Enjoy your week. Scores eventually. What did I miss in the chat? Cauchy integral formula? Alright, whatever. See y'all.